Welcome to this explainer. Okay, if you're an infrastructure engineer or a systems architect, you already know the grind. We're talking about the endless wrestling with manual SSL setups, containerization, database provisioning. It is exhausting. But today, we're unpacking something that completely eliminates all of that. Ajath's zero-setup, full-stack infrastructure. We're going to move way past the buzzwords and look right under the hood at the actual engine driving this massive shift in how we build cloud platforms.
Here's our roadmap for today. We've got 1. The infrastructure bottleneck. 2. AI engine primer. 3. The variance problem. 4. Ajath's multi-agent architecture. 5. Zero setup full stack deployments. And finally, 6. Scaling with infinite canvas. Let's get right into it.
Section 1. The infrastructure bottleneck.
Think about the traditional app lifecycle for a second. Honestly, it's a mountain of tedious, manual server configurations, right? You're wiring APIs, spinning up serverless compute, managing databases. The technical overhead is just massive. Now contrast that with this new era of what Google Cloud calls vibe coding. With vibe coding, you essentially act purely as the architect. You just use a natural language prompt, and the AI orchestration handles the heavy lifting of code generation and automated deployments. It completely democratizes the process, wiping out that cognitive load so you can actually focus on the logic itself.
Section 2. AI Engine Primer.
To really trust vibe coding in a production environment, we've got to understand how this works under the hood, starting with next token prediction. Rather than following strict grammatical or logical rules like traditional programming, LLMs are massive transformer neural networks. They're trained to basically just calculate probability distributions. They read your prompt, look at the vast context, and predict the single most probable next token. It essentially turns code generation into a massive supervised learning problem.
But here's the catch. Computers need numbers, not text strings. So raw text has to be processed by a tokenizer. Word-level tokenization is intuitive, sure, but it is incredibly brittle and causes a massive vocabulary explosion. Character-level tokenization fixes the vocabulary size, but it makes the sequences ridiculously long and you lose local semantic meaning. That brings us to subword tokenization, specifically byte pair encoding, or BPE. This is the industry standard for code generation. It elegantly iteratively merges frequent adjacent pairs. It keeps common words whole, but smartly splits up complex ones, like splitting unhappy into un and happy. This is the foundational layer making all this AI code generation possible.
Section 3. The variance problem.
Now you might be wondering, if it's all just math and probabilities, why does the AI sometimes spit out buggy code or slightly different answers for the exact same prompt? Well, for coding, developers usually set the model's temperature to 0 or t equals 0. This triggers what we call greedy decoding, meaning the model should, in theory, always pick the single highest probability token, giving you identical outputs every time.
But here is the wild reality of hardware. Surprisingly, even at temperature 0, you absolutely do not get 100% bit-exact determinism. Why? Because of GPU floating point non-associativity and server-side concurrent batching. Basically, operations processed in parallel on different GPU threads don't always sum in the exact same mathematical order. This introduces tiny, microscopic variations. And this perfectly explains why traditional single-chat AI bots get stuck in those agonizing, repetitive debugging loops when trying to build a whole app. The context breaks down, and the bot just endlessly loops trying to fix its own cascading bugs.
Section 4. Ajath's multi-agent architecture.
This inherent hardware variance is exactly why single agents fail at complex software. So, Ajath's solution? They completely abandon the single agent approach. Instead, their engine runs up to 10 specialized agents concurrently. You've got agents like Maya 4, Reina, Jacob, and Matt. Because they operate in parallel rather than sequentially, they completely prevent those compounding debugging loops. They are simultaneously writing back-end logic, handling the complex front-end UI, and securely managing the database schema design all at the exact same time.
It's honestly incredible to see this parallel orchestration in action. Maya 4 and the rest of the specialized team are building out secure authentication and complex schemas at the exact same time. It completely wipes out the traditional manual overhead that systems architects used to spend days or even weeks on. You aren't just getting a little code snippet, you're getting a coordinated team of AI engineers building a cohesive system simultaneously.
Section 5. Zero setup full stack deployments.
So we've seen how the code is generated, but how does it actually deploy? It flows through a beautifully automated pipeline. Step 1, you input your natural language prompt. Step 2, those parallel agents instantly get to work generating and debugging the code concurrently. And step 3, boom. The automated pipeline executes an instant zero-setup full-stack deployment. You skip the entire server configuration phase. No manual provisioning, no wrestling with SSL certificates, just instant secure hosting with pre-configured databases live from day one. On top of that, this infrastructure natively supports over 100 API integrations right out of the box. Think about all the time wasted on manual API wiring for stuff like Stripe for payments, OpenAI, or Google Workspace. Ajath removes that friction entirely. The integration is handled natively by the platform, letting you scale effortlessly.
Section 6. Scaling with infinite canvas.
To tie all this back-end power to the user experience, they use something called the infinite canvas, because modern development isn't just staring at command lines anymore. With the infinite canvas, developers can visually tweak layouts in a high-fidelity playground. And the real magic here is that as you make those visual tweaks, the parallel agents are instantly updating the underlying code pipelines in real time. It's a completely seamless loop between your visual layout and the hard-coded infrastructure.
As we wrap up this explainer, I want to leave you with a provocative thought. We've seen how tokenization actually works, how parallel agents crush the variance problem, and how automated deployments wipe out manual server setups. If parallel AI agents are now flawlessly managing the code generation and the entire zero-setup full-stack infrastructure, what will you architect next? When those traditional bottlenecks are gone, your only real limit is your vision. Thanks so much for hanging out with me to explore this incredible shift in technology. Keep building, keep learning, and I'll catch you in the next explainer.